Here we are on page 7. I think it's pretty cool if you read this page 27 of the book. Basically, the summary of it is how the quadratic formula came about, and it came about 700 years after Christ, and it was an Indian mathematician named Brahmagupta who made the almost complete version of it. So what does his look like? It looked like this: x equals b squared minus 4ac, and then he had minus b here. Okay, so here it says, what would you say to him to help him complete his solution? Well, I mean, it's not a big deal that his b is at the end, right? He could reverse the order, but it still wouldn't quite be right. So what would you tell him? What would you tell him so that he would have a complete solution? Okay? I think you can figure that out yourself. I'm not going to give you the answer here. For the simplest quadratic formula, what are the y, I meant equation here, quadratic equation. What are the y values corresponding to the first four x values? 0, 1, 2, 3. So instead of, so for the x value 0, 1, 2, 3, you will have the y values, and remember y is equal to x squared. The values would be 0, 1, 4, 9, right? That's pretty easy to remember, or you don't have to remember it, just calculate. What are the four conic sections, and why are they called conic sections? Okay, the four conic sections are ellipse, hyperbola, quadratic or parabola, and circle, which is actually kind of an ellipse, right? Okay. Why are they called conic sections? The reason why they're called conic sections is that they all can be made from a cone. Okay, cones look like that, like an ice cream cone. If you cut the cone in the right way, then you can find any one of these conic sections. So let's say I want to find the quadratic. The way I would find the quadratic is I would cut it parallel to one of the sides of the cone, like that. So if I wanted to shine a flashlight on the floor and get a reflection, an image on the floor of a parabola, what I would do is I would hold the flashlight kind of aimed down so that the top of the cone of the light was parallel to the floor. See? And if you do that, then the way the light is going to be on the floor is going to be a quadratic here. It's kind of tricky because, like, if you simply cut the cone like vertically like that, then actually what you're making is a hyperbola, which kind of looks like a quadratic, but it's different. Okay. All right. Now we're going to number 4. Some graphing problems here. Use the vertex, axis of symmetry, and y-intercept to graph the following. Okay. In this case, they're giving us the equations in vertex form, like we saw in our investigation, right? And remember that the vertex form already kind of gives you the vertex itself. So vertex form written generally looks like this: x minus h squared plus k. And so in this case, the h value is the x coordinate of the vertex, and the k value is the y coordinate of the vertex. So in this case, I'm going to look at this. I'm going to say it's minus 1. So the minus I ignore. And so the x value of the vertex is going to be 1. And the y value of the vertex is going to be 3. And so this is going to be my vertex. Okay? Now I'm looking for the axis of symmetry. Well, remember that the axis of symmetry is actually on top of the vertex. It's just the x value of the vertex. So the axis of symmetry is going to be x equals 1. The y-intercept. Now remember, the way you find the y-intercept is you know that the y-intercept is on the y-axis, and you know that all the points on the y-axis are at x equals 0. So if I want to find the y-axis, what I do is I put in x equals 0, I substitute in x equals 0, and then I get negative 1 squared, which is 1, plus 3, which is 4, so I get y equals 4 as the y-intercept. So my y-intercept is y equals 4. So now I'm going to use these this information to draw my parabola. And so I'm just going to draw my axes, and then I'm going to draw my vertex at 1, 3. And then I'm going to do my y-intercept at y equals 4. Okay, and then I don't really need to do the axis of symmetry because I already have the vertex, right? So I'm going to draw it bigger. It makes it easier. So here's the vertex right there. And let's see. Okay, kind of like that. Okay, I know that it starts at 0, goes to 1, goes to 4. You see, I can jump by the values that I put up here, right? Moving to the next one. Okay, so now the vertex I can see is going to be 1, 4, right? 1, 4. I ignore that negative sign because the negative sign is part of the standard vertex form. Now I know that the axis of symmetry is x equals 1. And last of all, I know that the y-intercept, if I plug in x equals 0, the y-intercept is going to come out. So the y-intercept is going to be negative 1/3 times negative 1 squared plus 4. Negative 1 squared is 1. Negative 1/3 times 1 is negative 1/3 plus 4 equals it's 3 and 2/3. Normally we don't like to use mixed fractions in advanced math, but for graphing sometimes it's nice. So here I'm going to have, let's see. I have to really blow it up here. So I'm going to have 1, 4 is the vertex. And then 3 and 2/3 is the y-intercept. 3 and 2/3 would be about there, right? So I can already see that it's going to point down, right? Okay, kind of like that. All right. And last of all, we got this one here. So the vertex of this one is going to be 1 and negative 3, right? So it's going to be 1, negative 3. The axis of symmetry is going to be x equals 1 because it's 1 there, right? And the y-intercept is going to be negative 2, and x equals 0 would yield negative 1 squared minus 3, and so it would be negative 2 minus 3, which is negative 5. So the y-intercept is going to be negative 5, and the vertex is going to be 1, negative 3, which is there. And so now I can see that it's going to point down, right? It's going to open down. Kind of like that. Okay, and so it just says to sketch using those 3 characteristics, so that's pretty much all I can do right now. Here it says locate the turning point or vertex for each of the quadratic functions, and you know, turning point just means like when a function is going up and then starts going down, or when it's going down and it starts going up. For a parabola, the turning point is the same thing as the vertex, okay? So first I'm going to show you the easiest way to do it without using the calculator. That would be, you would look for the A, B, and C coefficients, okay? And you would use the equation for the axis of symmetry, okay? If you know the exact equation in standard form, then if you put in the B and the A values into this formula, then it will give you the axis of symmetry, which is also the x-coordinate of the vertex, right? So it doesn't even matter what C is, okay? C could be anything, and the axis of symmetry is always the same. If you remember in the investigation, when you vary C, the parabola goes up and down, but that doesn't really affect its axis of symmetry. You also might remember in the investigation that when you vary B, you can see that basically the parabola moves in the opposite direction. So if you make b equal to plus 6, then the parabola moves to negative 3. If you move b to negative 6, then the parabola moves to positive 3. So basically the relationship was negative b over 2, right? But when you put a in there, when you start varying a, it kind of affects how far the parabola goes over, so it's kind of intuitive that it's negative b over 2a for people who've done the investigation. Okay? So let's put these numbers in. So b is negative 4. A is 1. So basically it's plus 4 over 2, which is 2. So the x coordinate of the vertex is 2. Now to find the y coordinate of the vertex, it's pretty easy. You just need to use the principle that if you know x, you can find y. If you know y, you can find x. How? Through the equation. So let's see. If we want to know the y, all we need to do is plug in 2 for all the x's, and we'll find out the y that corresponds to the x of 2, which is going to be the y coordinate vertex. Okay, so it's 4 minus 8 plus 2, so it's equal to negative 2. So the x-axis, x coordinate is 2, the y coordinate is negative 2. Let's do e like that too. So we have a equals 2, b equals 8, c equals negative 7. So we're going to have x equals negative b over 2 times a, which is 2. So it's negative 8 over 4, which is equal to negative 2, is the x coordinate. And the y coordinate we can find just by plugging in that x coordinate in for everything. So negative 2 squared plus 8 times negative 2 minus 7. So that would be equal to 2 times 4, which is 8, minus 16, minus 7. So that would be equal to 1 minus 15, which is negative 14. So the coordinates of the vertex are negative 2, comma, negative 14. Let's see. This one's a pretty easy one, actually. Once you plug it in, negative b over 2a, you will see that negative b, there is no b, right? Because this is ax squared. Bx has to be multiplied times x. There's nothing multiplied times x, and c corresponds to 4. So actually, a is 2, c is 4, but there's no b. So actually, b is 0. So the x coordinate of the vertex is 0. And then when you put 0 in for the 2x squared, it's 2 0 squared plus 4 to get the y coordinate. So you find out that the y coordinate is just 4. Okay, so it ends up being 0, comma 4. All right. And you can do this one the same way. The other way you could do it is completing the square. If you complete the square, you can find both the x and the y coordinate at the same time. Completing the square means you're going to change it to this form. Y equals ax minus h squared plus k, and then you're going to find out what h and k are. Okay. There's one other way to do it, which is with the calculator. I'm going to show you how to do that. Let's go to the y equals screen. You're going to put in the formula to graph it. 2x squared, right arrow, plus 6x minus 1. It came out kind of weird. Let's do zoom standard to start out with, and that'll, for a lot of problems, oh yeah, that's perfect. Okay, so we want to find the vertex. To find the vertex, the easiest way to do that is to do second calc minimum, because in this case the vertex also happens to be the minimum value. The left bound, we're going to move it to the left of the vertex. The right bound, we're going to move it to the right of the vertex. Make sure you move it well to the left and well to the right. It says guess. It doesn't matter what the guess is. You can go ahead and enter there. The guess only matters when you have multiple minimums, and you want to get as close as possible to the minimum. The minimum is negative 1.5, comma, negative 5.5. Negative 1.5, comma, negative 5.5. Okay. And you might say, oh no, the x coordinate is negative 1.500002. But actually, the calculator uses kind of estimation methods to find this. And so in this case, you know that you're going to end up with a whole number answer. So you know it's going to be negative 1.5 and not negative 1.500002. Okay? This one also does not look that fun to factor. But let's go ahead and use the axis of symmetry. Doesn't look that too bad. Doesn't look too bad. Negative b, which is going to be 1 divided by 2, and a is negative 1/2. Okay. So this is going to be negative 1 on top, and I hope you're good with fractions and multiplication. And this 2 times negative 1/2 is equal to negative 1. So actually x equals 1. So the y that corresponds to this point is going to be 1/2 1 squared plus 1 minus 5, which is equal to negative 5 plus 1/2, which is negative 4.5. So the vertex is going to be 1 comma negative 4.5. Okay. And we're done with this page.